Hello, ladies and gentlemen. Today we are going to start Chapter 12. And Chapter 12 is three-dimensional objects. So we're going to take a lot of our areas that we did in Chapter 11 and then apply them to three-dimensional solids. So the first thing we're going to talk about is a polyhedron. And you might want to pause the video and take down these notes, and then I will explain them. A polyhedron is a figure made up of 2D polygons called faces. So all of the polygons we talked about in Chapter 11 and other ones as well that we've talked about throughout the year, like trapezoids, rectangle, rhombus, all of those are two-dimensional polygons. And so a polyhedron is made up of all of those 2D polygons, and we call those polygons faces. Okay, so this right here is a face. And there are many faces in a polyhedron. The edges are where the faces come together. So this face right here and this face right here come together and form an edge right here. The vertices are where three or more faces come together, sort of the corner. So now if we take a look at the two faces I highlighted already and this one in front right here, now we have those three faces coming together and forming an vertice. So right here is a vertice. Okay, and we have one down here that's already marked right there. That's a vertex. It's also where really the edges come together. So this edge right here, okay, and this edge right here, and this edge right here, joining those two faces, they create a vertice. Let's see if I can find a good color here. There we go. Okay, all right. So kind of the corners. So if we look at sort of the anatomy, okay, kind of try to think about this, and you can, a visualization of an object that you're familiar with is like a tissue box. So let me use a different color. So think about a tissue box or a Kleenex box, and that's something that you can like physically look at probably in your house and compare this. So here again we have the faces marked right here. There's one face, okay? Here's one edge right here. Okay, here's another edge. Okay, where these faces and edges, so those are all edges, where they come together, that's where we find a vertex, like right here. Okay, a vertex. Here's another one right here. Okay, now there is a formula, Euler's formula, that for any polyhedron, the edges E, faces F, and vertices V are all related by this formula. Okay, this is one of those things that's just kind of helpful because it gets to be kind of difficult at times to count the number of faces. So for example, the number of faces we have in this polyhedron are 1, 2, 3, 4, 5, 6. Okay, so we have 6 faces in this polyhedron. Now if we count the edges that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 edges. Okay, so we have 12 edges. We could put that in right there. We have we said 6 faces, and then if we add the vertices minus 2, that will give us, we could actually solve this for V and not have to count them. And so this is kind of how and why this formula might be useful at times, rather than having to count all of the vertices. So if we count all the vertices, we have 1, 2, 3, 4, 5, 6, 7, 8. So the vertices is 8, and you can see that 6 plus 8 right here, that's 14 minus 2. It does equal the number of edges. So just helpful It doesn't come up that often. All right, so there are two types of polyhedron. Okay, there is a prism and a pyramid, and we're going to define each. Now, if we look at the pictures that are not polyhedron right here, okay, why aren't they? These are things we recognize. We know what a sphere looks like, a cylinder, and a cone, and we're going to talk about those in this chapter. But the reason these are not polyhedron is because they do not have what's defined as a faces. So there's no faces really here because they are not polygons. So there's no polygon faces. Also, it's because of the curves in there. So remember, a polygon is defined by 3 or more line segments joined. Okay, these are not line segments. We kind of talk about them in sort of the same way, but that's why these are not polyhedron, because there are no polygon faces to talk about. All right, so let's look at the two types. First of all, we have prisms, okay? Prisms are created by two congruent bases with a perpendicular height connecting them. So, and they're named by the shape of their base. Again, you might want to pause the video. But here we have the base. There's one base. That could also be flipped over and be a base, okay? Here's what you need to be looking for when you're talking about a base, because we could tip it on the side right here, but that is not going to be a base. And what we need to look for is that we need to look for that the bases have a perpendicular height connecting them, and the bases are parallel to each other. So that's what we are looking for. So this would be a perpendicular height right here that's connecting them. So this is called a pentagonal prism because the base is a pentagon. And again, we have these two parallel matching bases that are connected with a perpendicular height. Pyramids are created with one base and they come to a point at the top. So a pyramid only has one base. You can see there's not a base on the top and comes to a point. Okay, so we name these by the shape of their base. So this base right here is a triangle, so it's called a triangular pyramid. This base is a pentagon, so we call it a pentagonal pyramid. All right, so we first talked about polyhedrons. Okay, polyhedrons are made up, three-dimensional objects made up of polygon faces, connected by edges and vertices. There are two types. There are pyramids that we just talked about here, and there are prisms. So let's first figure out, can you determine which one of these are polyhedron, and if it is a polyhedron, what is it called? Well, this is a polyhedron right here, and it is a prism. Okay, and what kind of prism? Well, it depends on the shape of its base. Now, it looks like right here, it looks like a rectangular prism. It looks like a rectangular bottom. So I am going to make a leap that this is a rectangular prism. Okay, we do know that it's a prism. We just aren't 100% sure if that base is a rectangle. Same with down here. If we look at this one, okay, we might think that that is a square prism, but we really don't have the information. We could guess that it's a square prism, but to be accurate, we would have to have some markings like 4 congruent sides and 4 right angles. So let's look at this one right here. Is this a prism? And the answer is yes, it is. Some people at first get mixed up, but if you're looking at this, you see that this is coming to a point, but you have two bases, and that's how we know that it is a prism. Okay, so it is a prism, but what kind? What's the base? The base isn't always what it's resting on, and in this case, this is the base, because here's the congruent parallel base with this height right here connecting it. So this is actually a triangular prism. So you always have to kind of take a look at, look for that congruent parallel base that's connected by a height, a perpendicular distance between them. And this one down here, that is not a polyhedron. And it's not a polyhedron because it doesn't have polygon faces. Okay, it's got curves. Okay, so there are regular polyhedra. Okay, polyhedra is the plural for polyhedron. Okay, and in a regular polyhedra, all faces are congruent and regular convex polygon, and there are actually only 5 of them. So it's kind of an interesting fact. If we had more time, we might explore this a little bit more. There is some information in your textbook if you're interested in that. There are some polyhedron activities type thing. Okay, so now we're going to talk about what's called a cross section. And a cross section of a 3D figure right here is when you cut that 3D figure object into 2 pieces, and the shape that's created by that cut is called a cross section. Okay, so this cross section right there is a triangle. That's the shape of it. Okay, but it kind of depends on how you cut it. We kind of cut this kind of parallel to the base, okay, and it formed a triangle. But sometimes when you cut them at different angles, you get different cross sections. So this cross section right in here is a circle. Okay, that's the cross section, is a circle. This cross section over here, now that we've cut it a different direction, is a rectangle. And now we've taken a cube and cut it, and this cross section is now a trapezoid. So that's what a cross section is. So a lot of this first lesson is just kind of exploring and learning about terminology. So your learning targets here, you can read through them. And what I decided to try to do for homework in this, we'll see how this works, and maybe I'll gather some feedback from you. But what I would like you to do is take a look through the section and decide and choose what you need to work on. And I gave you some guidance, okay? This is a good place to start. Okay, but maybe you're finding, oh, I already know how to do that, and you want to explore some other more challenging problems than just what I've listed here. So you can decide, but you should choose several problems and not just 1, 2, 3. So make sure that you're choosing appropriately so that you're prepared for the quiz, which we'll quiz on after the first 3 sections. All right, if you have questions, email me or message me. I will probably host another Zoom session after another day or 2. Feel free to join and ask questions if necessary. Have a great day.